Hello, today we're looking at the intersection of three planes. Okay, so let's have a look at what we're being asked. So for the following system of equations, we got 1 and 2, solve using elementary row operations. And is the system consistent or inconsistent? If consistent, how many solutions, and interpret the result geometrically. Okay, so let's have a look. Let's start with the first one. Let's do it off to the left. Now let's pick a color, red. So we're asked to solve using elementary row operations, or elementary operations, what they call them. All right, elementary row operations. Okay, so let's label our equations 1, 2, and 3, so we know what we're referring to. Okay, so from number 2, we have y equals 2. Well, that's nice. So let's take that. This is interesting. I feel like we might have an error here. Or maybe not. Okay. All right, so, and then from equation 3, what do we have? Equation 3, we have x plus 1 equals 5, so x equals 4, right? This is looking easy. So for equation 1, we have x minus y minus z equals -1. Well, let's plug in y and x into equation 1, and we have 4 minus 2 minus z equals -1. So we have 2 minus z equals -1, or negative z equals -3, or z equals 3. Looks like we've solved. So it looks like we've done part A. Let's label that A. 1A. So it looks like our solution. Therefore, we have the solution, 4, 2, 3 is our solution. Okay. Is the system consistent or inconsistent? It looks like it's consistent. Be consistent, because we do have a solution, because we found a solution. All right, part D, if consistent, how many solutions? Well, it's unique solution, because we have a single point. And D, interpret the result geometrically. Point. Well, that was very easy. It's a lot easier than I thought. Good. So we solved using elementary row operations, and we found the point 4, 2, 3. So this means our system is consistent because we found a solution. We found a single solution, a point. This is a unique solution, and geometrically this is a point. All right, so now let's move over to the second problem. Let's pick another color. Let's use purple again. This one looks like it could be more challenging. Let's label our equations and let's see what we can do. All right, let's have a look at these first. See if we see any patterns. Okay, well, why don't we start with, to me it looks like the left-hand side of equation 1 and 2 are multiples. So why don't we do 2 times equation 1 and see what we get. Let's make it a little smaller. All right, so then we have 6x minus 4y plus 2z equals 8. And equation 3, we have 6x minus 4y plus 2z equals 5. Let's subtract. And we get 0x minus 0y minus 0z equals 3. 0 equals 3. I don't think we're going to get a solution. So therefore, no solution. Or rather, let's see what. can we solve? Solve. Not possible. Yes, no solution. No solution. All right, so that's linear system 2, part A. So that means B. So it's inconsistent. Inconsistent system of equations because we have no solution. Part C. Good. So part C and D are not applicable at this point. Oh, making a mess here, getting my letters all mixed up. Not applicable. Good. All right, so we'll review this one. So in the second system of equations, I noticed that equation 1 was a multiple of equation 2, except for the right-hand side. So this means we have two parallel planes. So then when I tried to start by solving using row operations, we found that we had 0 equals 3. That doesn't make any sense. So therefore, we have no solution. This means our system is inconsistent, and part C and D do not apply. Okay, so looks like that brings us to the end of our session today. If you have any questions, send us an email at info@raisemymarks.com or give us a call day or evening, and we'll be happy to answer your questions. Thank you for watching, and we'll see you soon.